Welcome back. In this lesson we'll be discussing bump and displacement mapping in V-Ray. The scene is extremely simple. I have this simple plane named wall, two cameras, this object named box, and this ear plane, and we're going to be unhiding them later on and using them. I have two cameras and a V-Ray dome light to light the scene. Let's quickly discuss what is bump mapping and what is displacement mapping and what's the difference between the two. The main difference between bump mapping and displacement mapping is that a bump mapping is just an illusion that won't alter the actual surface but just changes the surface normals to add detail to the surface. But displacement mapping actually changes and modifies the actual surface and vertices, and it's much more realistic compared to bump mapping. Let's go to the frame buffer and take a look at two renders. The first one was done using bump mapping to add detail to the scene, and the second one was done using displacement mapping. In the case of bump mapping, you see we have some details, but if you take a look at the outline of the plane and the shadows, you can see they are the exact same outline and shadows of the original object. But in our second render with displacement mapping, because we are actually modifying and generating geometry at render, you can see the outline has changed, the shadows and GIs are correct, and we are really having a beautiful realistic wall. Bump mapping is really useful for small high frequency details like wood grains, and it's a lot faster compared to bump mapping, but obviously displacement mapping is more suitable for getting larger alteration on our surfaces. Now let's see how we can set up bump and displacement mapping. Open up the material browser. This simple V-Ray material is the material that we have applied to our wall. Now we can start with bump mapping. If you select your V-Ray material and come down to the maps rollout, we have this bump slot that allows us to specify a block and white map as our map and control the strength of the bump mapping using this value here. So let's click on this map button for the bump. Choose bitmap and select brick disp.png as the bump map. The black parts of the map are going to cause indentation and white parts are going to cause bump, and the same thing is true about displacement mapping when we are actually using a grayscale map to control our displacement. If I right click on the material preview and choose open preview window, now let me just make the preview also a bit bigger. You can clearly see how the bump mapping is using the map to alter the surface, or at least give us the illusion of alteration. Also, we have the bump amount, which is by default set to 30. If set to 0, there would be no bump mapping. Let's use 30, maybe 60, 120, 200. As you can see, by increasing the value, we are just making the effect to be more pronounced, and cannot, for example, accept to have 200 centimeter of change in our surface, as bump mapping is just an illusion. Right click on the map and check show shaded material in the viewport. See how it's applied to our object. Let me just rotate it by 90 degrees on W and set the tiling to 2 and 2. Now we can take a look at a few renders with different bump amounts. In the first render, bump amount was 0, so we have our clean object without any change. In the second render, bump amount was 30. Now we start to get those dents and bumps. In the next one, bump amount was 120. As you can see, we didn't change the height, if you wish, of the effect. We just made the illusion more pronounced, more contrasty maybe. And in the final render, it was set to 200. So really, that's all about bump mapping. Now let me close the frame buffer and it's time to discuss displacement mapping. For now, let's disconnect this map from the bump slot. There are two simple ways to perform displacement mapping in V-Ray. First, it's from the V-Ray material. In the maps rollout, you can simply define a displace map and control how much displacement you want using this value here. After that, you can refine your displacement by going to the render setup dialog, and in the displacement rollout, under settings tab, control the quality of your displacement mapping using these parameters here. And the second way of performing displacement is gonna be using V-Ray displacement modifier. So you simply select your object in the scene, explorer, and add a V-Ray displacement modifier. Now you can define your black and white displacement here and refine the effect using these parameters in this panel. For now, let me just delete the modifier and get back to our material. Let me connect our displacement map to the displacement port. And let's set the displacement value to maybe something like 1 for now. I can use the same map as the diffuse map also, so we have a bit of contrast in our render. Now you are good to go and we can render the scene. Now in the render setup window, let's just change the render time limit to something like maybe 5 minutes and render the scene. This is the render with displacement amount of 1. In the next render, I increase the amount to 5, then 10, and finally 30. As I increase the value, you can clearly see each time we are literally displacing the object vertices more based on the map that we have defined. Now, if you want to fine-tune your displacement, you can do that in the default displacement rollout, as all of these options are actually available in the V-Ray displacement modifier. We are going to explain them there. The difference is that the options under default displacement rollout will affect all the displacements in the scene, but the options in the V-Ray displacement modifier obviously will only affect the objects that the modifier is applied to. So let's close our render setup window and disconnect the map from displacement port. And let me set the displace amount to its default of 100. Now let's select our wall geometry and apply a V-Ray displacement modifier. The first thing you need to do is to define a displacement map or texture. Use the map that's currently applied to the diffuse slot of the material and drag it as an instance to the text map slot of the modifier. And for now, I'm going to set the displacement amount to something like 7 centimeters. Now we can go through all the parameters that we have here. First, we have displacement type, 2D mapping, 3D mapping, and subdivision. 2D mapping method is great in preserving all the details in the displacement map, but your base object should have a valid UV. So if you want to use a 3D procedural texture like a noise map or texture that use object or world coordinates, you need to use 3D mapping or subdivision mapping. 3D mapping, in contrast with 2D mapping, can take any texture with any kind of mapping. And the way it works is it triangulates the base geometry and then subdivides those into smaller triangles and then displaces them. Subdivision method is very similar to 3D mapping in how it works, but it also tries to subdivide and smooth out the edges. Like for example, Open Subdiv or Turbo Smooth modifier that we have in 3ds Max. So you can use this type to actually smooth your object if the amount is set to 0 and not displace the object at all if you want. Or you can do both at the same time if the amount value is bigger than 0. Now let's take a look at 3 renders with different displacement types. The first one is 2D mapping. The next one is 3D mapping. And finally, subdivision. I can't see any noticeable differences between 3D mapping and subdivision, maybe some slight differences in the way they handle the edges, but 2D mapping is actually trying to preserve more of the details. Right now, generally speaking, 3D mapping and subdivision types are preferred methods as they don't have many of the limitations of the 2D mapping. For now, let's set the type to 3D mapping, which is the default type. Down here we have our common parameters, which are common to all the displacement types. First, you can define your displacement map using the text map slot here. Then we have texture channel here, and here you can specify the UVW channel that will be used for displacement mapping. Then we have a filter text map checkbox, and if enabled, the texture map will be filtered. And here using filter blur, you can control the strength of the filter. Other filter settings can be found in the image filter rollout under V-Ray tab in the render setup window, which we discussed in the previous section when we were discussing image sampling. Now let me show you a few renders with different filter settings. In the first render, filter text map was off, and as you can see, we get this very rough surface as no filtering has been applied to the map. In the next render, filtering was on and filter blur was set to 0.001. Now we apply a tiny bit of blurring or filtering to the map, and the overall result is smoother. We can compare this render with the previous one. And in the final render, I have increased the filter blur amount to about 0.5, which is significantly blurring the image. And as there is less detail in the map, the displacement map is not defined at all. Now, let's set the filter blur again to 0.001. Next, we have amount, which is the amount of displacement mapping. Obviously, the higher the value, the higher the displacement is going to be. If the amount is set to 0 and type set to subdivision, the modifier will only smooth the object without displacement actually happening. We can use negative values here. In that case, the effect of displacement mapping will be reversed. Next, we have shift, which literally shifts the displaced surface up and down along the normal. As you can see in the first render, shift value was set to +10, and in the next one it was -10. As you can see, it literally moves the surface. Now let me make sure shift is set to 0. We have water level, which clips the surface in places where the displacement map value is below the specified value here. So let's enable water level and set it to something like 1 centimeter. This is the render with water level set to 1 centimeter. And in the second one, it was set to 2 centimeters. And you see how this value tries to clip away the surface. Now let me set the water level back to 0 and disable it. Then we have relative to bounding box. When enabled, the displacement amount or height is based on the bounding box of the objects, and when disabled, which is by default, displacement height is expressed in generic world units, where white areas in the displacement map correspond to a displacement of 1 generic unit. And I'm quoting from Kiosker website for this one. Next, we have this text map min and max, and by default they are set to 0 and 1. If your displacement map contains negative information, you need to set this value to -1 and +1 to be able to see that those actually negative texture values are actually pushing your geometry in the negative direction. Next, we have 2D mapping parameters, which became available when the displacement type is set to 2D mapping. First, we have resolution, which determines the resolution of the map that will be used for displacement mapping. And it is best to set this resolution close to the actual resolution of your displacement map. Our map here is 4K, so if we are using 2D mapping, it would be better to set this value to 4096 pixels. Down here we have tight bounds. When enabled, V-Ray will compute more precise bounding volumes for the displaced triangles, leading to slightly better rendering times. Then we have 3D mapping and subdivision parameters. So let's set the displacement type to 3D mapping. First, we have edge length, which is the main parameter to control the overall quality of the displacement mapping. As we mentioned in the displacement mapping process, the original mesh will be subdivided into smaller and smaller triangles. And the more and smaller triangles we have, the more detailed the displacement mapping would be, and vice versa. Edge length controls the maximum length of a subtriangle edge. The smaller the value, the higher the quality of our displacement mapping, but at the cost of slower renders and more memory usage. In the first render, edge length was set to 50 and we get no defined displacement at all. The next one is 20. It's a bit better, but we still lose lots of details. The next one was set to 4, which is a default value, and the final was set to 2 pixels. In this case, we get a little more detail when set to 2 compared to 4, but I think 4 would be enough in this case. View dependent is the unit for edge length parameter. When enabled, edge length is in pixels, and when disabled, it's in world units, which is centimeters here. Use object material if enabled and you had a map connected to the display slot of your vary material. That map will be used instead of the map you have defined up there in the text map slot, or if you haven't defined any text map here, and simply you can turn this option on and the modifier will use the map that is connected to the display slot of your vary material. Some of the options are grayed out. These are subdivision types options, and we're going to take a look at them in a moment. Down here we have keep continuity, which if enabled tries to produce a connected displaced surface. I have this box in the scene, so let me hide the wall and unhide the box. In the material editor, let's copy our main material by shift dragging. Now assign the material to the box. Let's check how the map is applied onto our box. Maybe we can set the tiling to something like 0.5 and 0.5. Now let me select the wall geometry, copy the displacement modifier and paste it on the box. Now because we changed the tiling of the map, let me just use this newly copied map as our displacement map for this displacement modifier. Now let me show you two renders with and without keep continuity. In the first render, keep continuity is off and we get this disconnected geometry, and in the next one it is on and we get this proper connected geometry. Next we have edge threshold. When keep continuity is enabled, this value controls the extent to which maps on faces with different material IDs will be blended. Before talking about vector displacement, let's change the displacement type to subdivision and see what parameters does it have. First, there is this max subdivs, which controls the maximum subtriangles generated from any triangle of the original mesh. So the actual number is the square of this number as other subdiv values. So make sure to cautiously alter this number all the time. Let me show you how it works. First, let's set the displacement amount to 0, and now because we are using the subdivision type, we can only smooth out our box without performing any displacement. In the material editor, disconnect the displacement map from the diffuse port. Let me add a V-Ray edges text map and connect it to the diffuse map, and let me just enable show subtriangles here. V-Ray edges text shows the edges of the geometry in a specified color, which is white here. And we'll be talking about these maps in their specified lesson or maybe section. Now we can run the active shade. Let's first set the max subdivs to something like 1, so we get our box and its original triangles. And as we increase this number to 2, 4, and 8, each time we add more subtriangles, and because the displacement amount is 0, we smooth out our cube as well. Now let me stop the active shade and set the max subdivision to its default of 256. Next we have classic Catmull-Clark, and if I quote chaos group, when this option is enabled, V-Ray will use the classic Catmull-Clark method for subdividing the mesh instead of the hybrid one used by default. This option should be enabled only if the mesh is composed entirely of rectangular faces, or it will not work. When smooth UVs is enabled, here, not only the geometry but also the UVs of that geometry will be subdivided. And if smooth UVs is enabled, preserve map boundaries dropdown will determine what will happen at UV boundaries. When set to all, none of the boundary UVs will be altered. When set to internal, only the internal boundaries will be preserved. And when set to none, all the boundaries will be smoothed. Let me disable smooth UVs and change the type to 3D mapping again. Finally, we have vector displacement. If you have a vector displacement map generated in a software like ZBrush, Modbox, or any other tool, and it has more information compared to a simple grayscale map, you can use this option. If your map was generated at a tangent space, you need to set this to tangent space, and if you are using a V-Ray PText texture, which we'll be discussing later on, you need to set this to object. In the material browser, let me just delete this V-Ray edges text. Also, let me just turn off keep continuity for now. Set the vector displacement mode to tangent. Now click on this text map slot. Choose bitmap. And if you come down, we have this ear vector displacement texture. Let's select that. And set the displacement amount to maybe 8 centimeters. Let me hide this box and unhide this ear geometry. And paste the displacement map on this object. Now let's just move this plane a bit. Maybe we can rotate it as well a bit. Also, let me just go to the material editor and apply our simple V-Ray material to this object. Now let's render the scene in the production rendering mode. Now, as we can see, we get this very complex displaced ear geometry. Let's maybe stop the render and we can save it in our history list. Finally, we have some 3D performance options, and I'll be quoting from V-Ray official help to explain these parameters. Tight bounds, when enabled, V-Ray will try to compute the exact bounding volume of the displaced triangles from the original mesh. This requires pre-sampling of the displacement texture, but the rendering will be faster if the texture has large black or white areas. However, if the displacement texture is slow to evaluate and varies a lot between full black and white, it may be faster to turn this option off. When it is off, V-Ray will assume worst case bounding volumes and will not pre-sample the texture. Note that this option affects only the 2D mapping and 3D mapping modes. With the subdivision method, V-Ray will always compute the exact bounding volume, and this parameter is ignored. We have static geometry. When enabled, the displacement geometry is precompiled into an acceleration structure at the beginning of the rendering and remains there until the end of the frame. This can speed up the rendering but will increase the memory usage. We have cache normals. When this option is enabled, V-Ray generates and saves information about the normal of each newly generated vertex. This requires additional memory but speeds up the shading calculation during rendering. Okay, so for our final render, I'm going to hide this ear object and unhide the wall. In the material browser, we are going to be using another diffuse map. So let's disconnect the current map, copy the displacement map, and connect it to the diffuse map. Now let me select that map and replace this texture to brick diffuse.jpg. Also select the wall and set its displacement amount to maybe 4 centimeters, and let's take a look at the final render. So there you have it. That's our final render. The second render is from our second camera. And in the final 2 renders, I have used the same displacement map for diffuse map also. Perfect. So that's about bump and displacement mapping in V-Ray. I will see you in the next lesson.